Thank you for joining us. So yeah, Val is going to talk about Ignite 3.0, where things are going in, well, I don't want to steal his thunder, so I'll just pass straight over to Val.
Yes, thank you. Thank you so much, Steven. Yeah, so I would like to talk for the next 15 minutes about the future of Ignite and what we're currently working on in the scope of Ignite 3 project. So if you haven't heard yet, Ignite 3 is essentially an attempt to create the next version of Ignite, the next major version of Ignite, with some major changes that I will go through. And essentially, it will be the next generation of the platform with some exciting, cool changes that hopefully will make Ignite better. So we started the project last year, like around October, I think, if I'm not mistaken, and there were actually multiple drivers behind this whole initiative. But the main story here is that Ignite 2.x has been in existence for a while. It is there for several years, and essentially what happened is that it went through significant transformation in terms of like what kind of use cases it covers, in terms of what kind of features and functionality it provides, and this kind of things. Like we didn't have persistence at first. Now we have persistence, which is obviously a huge change. But it never went through any significant architectural change or API change. And as a result, we have a very flexible, very powerful system that can do a lot of cool stuff. But at the same time, it's not super easy to use, and it's not super adaptable for newcomers. And also, it kind of accumulated a certain amount of technical debt because of all that. So these are the main things that we want to address in Ignite 3. So there are two main goals that I would like to emphasize. First of all, just general modernization of the platform. So we want to get rid of some legacy stuff, of some legacy formats, legacy protocols, and I will give some of the examples of that. And also make replace it with something more modern and more usable, and also make the platform more cloud native, because we have more and more cloud deployments nowadays. It becomes more and more important. So we want Ignite to be deployable on the clouds, and we want to make it easier to deploy on the cloud, in the cloud environments. And the second goal is to improve usability, like overall usability of the product, of the platform, and overall kind of developer experience of the platform. Again, as I said, it's a very flexible, powerful platform, but it's not always easy to use. So we want to simplify installation and upgrade procedures. We want to rework the way Ignite manages configuration and data schema. And I will also go into a little bit detail there as well. Ignite 3 will provide a Unified Cli tool, which is pretty cool. It will kind of give you all the possible operations in a single place. So again, just general usability improvement, make the developer experience much more pleasant, make Ignite much easier to use, and much more adaptable for newcomers, people who just download Ignite and try it out. So let me go through several modules, several companies that we're currently working on. Some of them are already available. Some of them will be available in the nearest future in one of the alpha releases. So first of all, it's a new configuration engine. So we want to get rid of the legacy XML format, which we're currently using for configuration. This format comes from Spring, and even Spring doesn't really use it anymore. They switched to annotations for the most part. And we want to use Hawken format instead, which is a library from Lightband, which was created for pretty much these kind of purposes. You can think of it as a kind of human-readable JSON. And it's also compatible with JSON as well as and Java properties formats, which is really cool because it kind of gives you this flexibility. This engine will provide clear separation between static and dynamic parameters. So what this means is that current Ignite 2.x has all the configuration static, which means that you have a configuration file, you start a node with that configuration, and then there is no generic mechanism to update that configuration. So yes, there are certain kind of knobs here and there to change certain parameters through certain specific procedures, but there is no consistent mechanism to do that. So in Ignite 3, you will have static parameters, you will have dynamic parameters, and you will always know which are static and which are dynamic. And for dynamic parameters, you will have clear unified API to update them. And you will be able to update those parameters in runtime without any unnecessary cluster restarts and without unnecessary downtimes. So the second change is what we call schema-driven architecture. It's kind of a big topic, but essentially in a nutshell, what it means is that we will have one-to-one match between tables and schemas. So whenever you create a table in Ignite, you will also provide a schema for that table, and you will do that explicitly, right? So with Ignite 2.x, it can be a little bit convoluted because we have SQL schema, we have binary object schema, and those two are kind of managed separately. And then you also work on top of caches, which are essentially schemaless. So it can be a little bit counterintuitive in certain cases. So we want to get rid of this and create this clear one-to-one match so that the behavior is much more predictable and much more intuitive. And it will also provide guaranteed consistency between schema and data at all times, which means that whenever you update something, you insert the data or you update the data, update a record in the table, this update must be compatible with the current schema of this table. And also, whenever you update the schema, it also that update will also be reflected in the data. So let's say you remove a column in a table, then all the values that correspond to that column will be eventually removed from that table, cleaning up the space and creating this consistency. So, and we also will have the unified API for dynamic schema updates. Again, similar to configuration, we'll have clear API, which will allow you to update, to do those schema changes in runtime without cluster restarts, without any kind of additional cluster manipulations. And we potentially will have multiple different APIs for that. We'll have the Java API as a basis, and then we'll build REST API on top of that. DDL, of course, will also utilize that. And one of the great things here is that all those different APIs will utilize the same underlying mechanism. So this is kind of one of the requirements that we put there. So what probably the biggest change in terms of usability is the Unified CLI tool. So the idea behind this is that instead of downloading a huge zip file with like a lot of different files, a lot of different jars and other stuff, you will download. You will have a very lightweight download, maybe a single file, maybe just a couple of files, and this lightweight download will be actually a CLI tool that will be an entry point into everything else associated with Ignite, into every other functionality. So this tool will allow you to install the core artifacts of Ignite, install Ignite locally, upgrade it. It will allow you to manage optional modules as well as external dependencies. You will use it to start, stop, restart nodes, manage configuration, like update those parameters. So those APIs will be exposed in the CLI tool as well. Manage the schema, create tables, change the schema of those tables, and so on. And pretty much anything else that we can think of will be exposed in this CLI tool. So all the operations will be executed from the CLI tool. So one more thing we're working on is updated data replication protocols. So there are several things there. It is even bigger topic, I guess. So first of all, what we've created already at this point is what we call a common replication infrastructure. One of the kind of internal architectural issues that we have with Ignite 2.x right now is that it utilizes different mechanisms for in different places to do pretty much the same thing, to replicate the data across the nodes. Like we have, partitions in caches, and they use certain protocol for replication, and then we have metadata, which is also maintained by Ignite itself. And Ignite sometimes would use, kind of system caches for that, essentially reusing the mechanism, but sometimes it would use a completely different protocol for that. So we wanted to unify that. So it's more of an internal thing, of course, but this kind of helps us to create better architecture within the platform itself internally. So we created this common replication infrastructure, which is based on Raft, which is well-known, battle-tested protocol. So we've chosen that one. And this actually brings several benefits. So first of all, the transactional protocol that we will build on top of that will run on top of partitions. So it will kind of treat those partitions as primitives, as replication primitives, which brings a couple of benefits. First of all, that means that there is no performance penalty for collocated transactions. So whenever you run a transaction which is collocated within a single partition, it is essentially the same as providing atomic consistency, maybe with some additional local locking, which is very cheap, right? And there is also no separation between atomic and transactional modes. So we don't need those different modes anymore as we have in 2.x. So if you want to run a transaction which is collocated, it will just be applied on a single partition. If you want to run a transaction which is cross-partition, then the additional transactional protocol will kick in only kind of on demand, and this will happen automatically. So it simplifies configuration and again improves the developer experience. And also as a bonus benefit, it kind of improves split brain protection because we use those well-known protocols which are kind of designed to handle split brain protection situations. And also we will be able to get rid, or at least get rid of partition map exchange, which is our kind of internal mechanism, or at least make it less frequent, which again improves kind of the overall stability and of the system and developer experience as well. And this is kind of an honorable mention because the development of the new SQL engine started way before we even thought about Ignite 3, actually. But it's currently targeted towards Ignite 3. So this Apache calcite-based SQL engine will appear in Ignite 3.0. We will not have it in Ignite 2.x. Essentially, this is just the replacement of the current H2-based engine. H2 has limitations, and we have kind of more and more issues dealing with those limitations. And Apache Calcite is essentially a perfect match for what we are doing with SQL within Ignite. So we want to replace H2 with Apache Calcite, and that will kind of open multiple roads into wider SQL support, into multiple different optimization algorithms that we can apply that we cannot apply right now. And it's just overall, much more efficient than H2 in terms of memory consumption, CPU consumption, and whatnot. So we expect SQL to be much faster with Calcite comparing to H2, and also it will allow us to provide more functionality to going forward. In terms of the timeline, we already have Alpha 1 released. It actually happened kind of several months ago. If you haven't seen it, you can check this blog post, and as well as the video series where I kind of play with all those different features. It demonstrates, very basic things like how you will download the CLI tool, how you will use the CLI tool and some basic operations around configuration and starting the nodes and whatnot. Very soon, I guess within a month, probably even less, we will have one more alpha release, Alpha 2, which will provide table and schema management APIs, which is kind of a big milestone, and I think it makes sense to create an alpha release with this enhancements. And it will also have the kind of the atomic storage implementation. So you will be able to start a cluster, put some data in it, and then read some data back. And kind of get an idea of what Ignite 3 will look like in terms of the APIs. And then finally, we hopefully will have functional beta version sometimes, by the end of the year, maybe Q1 next year, potentially. It might not have some of the features of Ignite 2.x, like, continuous query, service grid we might add them later going forward, but it should have kind of the core functionality ready so that you can try it out and see how it all works. So before we go into questions, I wanted to spend just a couple of minutes, quick kind of a sneak peek into the APIs that we're working on. So I've created this simple code. I'm not going to run anything because not all of it works, but it will work in this Alpha 2 release. So stay tuned, follow the dev list. The way it will look like is, you will start Ignite pretty much the same as we had before. So you have like a start method, which gives you an Ignite instance. That's very similar to what we had in Ignite 2.x. But then when you create a table, and that's where we have differences, right? So when we create a table, you will provide the schema for that table. So this is the Java API, which we probably will change as well, and we will have DDL on top of that, of course, so it will be much less cumbersome going forward. But the idea is, again, that when you create a table, you always create, you always provide the schema, and it is explicitly provided. And for any table, you can always kind of check what the schema is. And then we have multiple different APIs to work with the data. So first of all, the basic API is what we call Topple Api. So all the records in the table are just tuple. They are a collection of values. And you can use this tuple builder to build those records, to build those tuples. This is kind of similar to binary object builder that we had in 2.x, although a little bit more focused on the data storage format, on kind of building the tuples for the data storage, rather than being this universal serialization protocol. But then if you don't want to use the Topple API, you can create views. You can create a key value view where you provide classes, like you can have a key class and the value class, and you provide them here. And that creates the key value view on top of that same table. And the point is that it doesn't really change the mechanisms under the hood. It only creates a view. So it only kind of does this serialization, deserialization for you. So it's a facade on top of the same exact table with the same exact schema, right? So this class has to correspond to the schema that you have. And if you update, you need to change the class as well. And there will also be what we call a record view option, where you, instead of kind of splitting those fields into key and the value object, you have a single object, which might be suitable for some of the use cases. And you don't always have to have all the fields in the in your view. You can have only like a couple of them. Let's say like here we have only the primary key, and then Ignite will only read the fields that you need in this case. And again, this will happen automatically, and you don't really need to manually manage that. So all that will appear in this next alpha, and it will work in the next alpha. So you will be able to download and play with it. So I would definitely recommend you to follow the dev list, see what is going on there, and hopefully we will get this release very soon. So with that, thank you so much, guys. And if there are any questions, if we have time, I'm ready to answer.
We see. Thank you for that, Val. Kind of very interesting. It's good to see the code. Actually, I've heard about this in theory before, but actually seeing what it looks like makes a difference to me, at least. That's true for lots of other people. So one question came in from Ivan Dasinsky. Excuse me, but the current calcite dev branch are derived from 2.x and depends on 2.x. Why do you think the calcite engine will not be merged into 2.x and released in the coming release?
That was one of the decisions between the community. Yeah, of course, like the development, as I said, development of the calcite engine started before we started Ignite 3. So, therefore, for now, it is actually in the Ignite 2.x repository in one of the branches, but it will be migrated to Ignite 3. Because basically, Ignite 3, we kind of think that Ignite 3 should have all those new features, and Ignite 2.x will be our stable version for the next certain amount of time, because obviously Ignite 3 will take several months, if not like years, to become stable and to come to this state where you can use it in production and whatnot. So 2.x is stable, and it will continue using the existing engine, which has a lot of functionality, and it's actually well stabilized and optimized at this point. And we'll put the cal site along with all other new developments into 3.x.
Sounds good. And the APIs kind of look very different. Is there any kind of thought on how you could kind of migrate from the 2.x branch to 3.x branch if you've written a lot of code?
The API is different, although, of course, it will not be kind of fully compatible. Although I think it will have a lot of similarities provided by those views, first of all, right? So yeah, the basic API, which is this Topple API, where you work with tables directly, that one is completely new. And this API is something we need for to provide this proper schema management that we're looking for. But then you have key value views on top of that, which are very similar to key value API that we have right now. It will have pretty much all the same methods. We, of course, will have SQL, which will be still SQL, right? And compute will probably not change a lot, especially in the first versions. I think it will be pretty much moved as is from 2.x to 3.x. So a lot of APIs will either stay the same or be similar. Of course, it will require certain migration, and we'll have migration guides, and probably we'll also need some data migration tools because data format is different. So yeah, it will be some effort to migrate from 2.x to 3.x, but we of course are looking at how we can minimize this effort for it.
Great stuff. Well, really appreciate your time in talking through this stuff.